Hi, I'm Nima Zargham from the Digital Media Lab at the University of Bremen, and I'll be presenting our paper, I Didn't Catch That, but I'll Try My Best, Anticipatory Error Handling in a Voice-Controlled Game, that I did together with Johannes Pfau, Tobias Schnackenberg, and Malaka. Voice user interfaces are gaining more and more attention in recent years due to the intuitive nature of their interaction. Voice input is now a feature in many devices such as mobile phones, cars, and home assistants, and are used for several purposes such as smart home control, scheduling, navigation, or education. Recently, this technology has gained considerable attention in the entertainment industry, and video game companies have been adapting voice-activated services to their games. Although the rate of VUI studies has increased in recent years, research on voice interaction in games is rather limited. Early research on voice interaction in digital games roots back to the 1970s, where voice chess, a game which could support standardized chess instructions using speech recognition system, was developed. With the introduction of Kinect, many game companies in various genres took advantage of the voice interaction that was provided by Kinect. Also, there have been several voice-based mobile games in the market which have been quite successful. Although there are plenty of examples of video games that use a speech-based voice interaction, those which use non-verbal forms of voice input such as volume and pitch have been more successful. The reason behind the success of such games is that they avoid recognition errors entirely. Previous research has shown that problems with speech recognition and limited functionality are the main reasons for disliking or not using voice systems. This makes error handling a critical part of designing VUIs. Several guidelines for designing fallback strategies have been proposed, such as asking users to repeat the command or redirecting users to the tasks that the system can support, presenting users options to correct their command, and in some cases, falling back on humor. Video games, however, are mainly goal-oriented activities, and players find enjoyment when they work towards this goal. If the challenge is right, the players are in a state of flow. The misrecognition of voice input in video games adds another layer of challenge on top of the game's existing obstacles, preventing players from reaching their goals and staying in the state of flow, which often results in player frustration. Studies have shown that once a recognition error occurs, the likelihood of having an error in the next intent increases. One of the reasons for this is that as more errors occur, the user's patience runs out and frustration increases, which can lead to acoustic and language mismatches. Human operators often do not signal when they don't understand the color, but rather try to advance the task by asking a different question, which generally leads to a speedier recovery. On this basis, we designed Listen Sparky, a speech-based video game to investigate the player experience with two different error handling methodologies. In this game, players are in control of the sheepdog Sparky, who has to guide a sheep through restricted courses and keep away hazardous encounters. Players impersonate a shepherd that gives directions to the sheepdog. The game consists of 8 levels. In every level, players have to safely navigate and return a sheep that has escaped from a meadow to the gate. The game controls consisted of 5 interactions, where the system was able to handle multiple phrases per interaction. We developed 2 versions of the game. In the control group, the game would notify the player of the recognition failure so that the player could repeat the command once again. For the intervention group, we developed anticipatory error handling. If a command was not recognized, the game would proceed by performing a locally optimized action in respect to goal completion and obstacle avoidance without notifying the player about the recognition failure. The game would first prioritize not getting eaten by the wolf and then would consider the action which would position the sheep closest to the gate. In this study, we wanted to answer the following research questions. Does performing a locally optimized game action in times of misrecognition lead to a measurably improved usability in a speech-based video game? And what are the effects on player experience in terms of competency, autonomy, presence, and intuitive control if error handling mechanisms decide for unintended actions? We conducted a between-subject user study with 34 participants between 22 to 43 years of age. The experimental sessions were held remotely via video calls. Each participant had to play all the 8 levels and fill in the post-exposure questionnaires, including demographic questions, the system usability scale, as well as the player experience of need satisfaction. In our evaluation, we did not consider the subscale of relatedness as it was not relevant to the scope of this study. We concluded the sessions with a brief semi-structured interview to further evaluate qualitative aspects of player experience, usability, and individual preferences for both conditions. Overall, users' feedback about Listen Sparky were rather positive and supporting. Participants specifically pointed out that controlling Sparky with voice made them feel more immersed as they felt like an actual shepherd. On the other hand, many players expressed their struggle with the recognition of their commands, especially in the beginning of the game. But they improved after spending some time in the game. They learned how to formulate their commands and speak clearly to be recognized by the system. Players often performed worse when they were under time pressure. Our results showed a significantly higher usability, as well as higher ratings of intuitive control for the version employing anticipatory error handling. Although participants of the intervention group committed more errors on average, they in fact reported a significantly lower amount of perceived errors compared to the control group. Players of the intervention group were reportedly confused by Sparky acting against their original intention, resulting in a misleading learning experience that impaired in-game progress and proficiency attainment. Even if quantitative insights suggest a higher usability through the anticipatory error handling intervention, qualitative statements underline that this increase of usability is mainly due to the cases where the error handling actually followed the user's intention, which was not always the case, even when deciding for technically optimized solution. We observed a feeling of dissatisfaction when the handling did not follow users' initial intention. Overall, we witnessed contrasting opinions regarding our proposed method. Some were in favor of anticipatory error handling as it helped to keep the flow of the game. Some didn't like it as they believed it hides the problem rather than solving it. One participant also proposed performing a random action rather than optimize one to make the game more challenging and add an element of surprise. Considering all the differences in the opinions, one can assume that the optimal solution could differ from one player to another. Game developers can consider equipping different methods as optional features of the game, where the players can choose their desired methods based on their own preferences. In this study, we witnessed that players did not necessarily favor the cases that the anticipatory error handling was used if the action did not match their initial intent. One could assume that having full control over the game and perceiving a feeling of agency could be rather preferred, even if their actions are not the optimal ones towards level completion. Therefore, more effort should be put on understanding the user's initial actions rather than finding the optimal action. Future work will extend this work by approximating the user's intention even further by creating user models. Furthermore, aspects such as player types, mood, and game genres need to be investigated in order to gain a deeper insight in this regard. For further details regarding our work, please refer to our paper and feel free to contact us.